Welcome, everybody. Today we have a session around Fluent v4.1 that is coming out right now. And this short presentation is a very high-level overview of what's coming out in this major release. Okay, for those who are not familiar, this specific session is being sponsored by Chronosphere, and who's presenting now is Eduardo Silva. I'm creator and maintainer of Fluent. I'm a software engineer at Chronosphere, and I have been around the CNCF and Linux Foundation for a while. And of course, I'm part of the Fluent organization team. One of the problems that Fluent solves for those who are new watching this video is like when you have multiple sources of telemetry data, meaning like logs, metrics, traces, and you would like to move this information to a central place so it can be analyzed by your providers, right? You need the right tool for get the job done. And that is Fluent, which support more than 100 connectors between sources, destinations, and many type of processors in terms of to filter or enrich data with Kubernetes annotations, metadata, labels, or for example, extract Prometheus metrics and maybe remove certain dimensions or labels that comes with the metrics. And same type of processing can be applied to data that is being generated, for example, from an OpenTelemetry protocol in case you have your own application instrumented with OTLP. So Fluent has been around for 10 years. And there's a few things that are really important to mention about the project. And primarily are the key principles that drive Fluent. And I would say that we always remember that these are three. One of them is try to be really high performance at a low resource usage. So we always try to optimize for the speed, efficiency, and try to reduce everything that is around CPU usage, but without sacrificing the performance. And of course, if you use less CPU, you use less energy. We are a vendor-neutral project. That means that it aims to integrate with everybody, even competitors. Okay, and of course, within the CNCF ecosystem, we connect with Prometheus, with OpenTelemetry, and many other projects in a way that it allows you to just use this utility, right? Getting right away the value, just integrating with the right sources and destinations and adding the processing that you might need. And in order to be vendor neutral, also, and as I said, we integrate with others. That's why we have an extensive plugin ecosystem. So Fluent is a small core that has a pluggable architecture that allows you to extend it in many ways as possible. Fluent, it's part of the Fluent ecosystem. So it's considered a sub-project of Fluent, which is a graduated state. And now, before jumping into what is new in 4.1, let's do a recap of what is JSON encoding, because many of the performance improvements that we did are about JSON. So let's take a look how JSON encoding works, and then we will get the details about what are the improvements that were made. So JSON encoding basically is a structure, and that says, hey, you can have numbers or floating numbers, you can have strings. And when you have special characters, like for example, a quotation mark or a backslash, that needs what is called escaping. The way that you encode JSON is by doing escaping, right? For example, a JSON does not allow the ASCII break line on the \n, right? Directly as an ASCII code, you have to escape it with, of course, a new backslash. And the same thing happens with any type of characters. So everything that should be one character becomes ending two. And yeah, this is not a problem. Historically, we have seen that readable human formats always helps. Consider HTTP 1 versus 2, or consider JSON versus other binary format. Of course, JSON is human friendly. It's not loved by everybody, but gets the jobs done. However, send is something preferred by the users and by everybody. Yeah, we have some challenges when it comes with a volume of data that comes in this format, or a volume of data that needs to be encoded in this format, because the remote endpoint where we're sending the data expects JSON. So if you read this text, right, which says hi and bye, you might imagine that or try to count the bytes that exist in here. And you will say that, oh, this is high, then you have a break line, and then you have byte. Of course, there you have like 6 bytes, right? But this \n needs to be escaped. Okay, this is just text. This is not JSON. But when this becomes JSON, of course, it increased in 1 byte. And if you think about this, this is not a big deal. Oh, this is done automatically, right? But when you have a long text and you want to encode it in JSON, you need to be aware about all these special cases like special characters or UTF encoding that needs some special handling. And what happens at the end is like your original text becomes a larger text represented in JSON. Okay, so if we have this, let's call it a table with a lot of symbols, and you want to encode this in JSON, likely you will need to find or need to check every character and see if this needs to be escaped or not. For example, if we just do a quick look, oh, we will see, oh, these quotation marks or this \n/t needs to be escaped, right? To perform the JSON encoding. This is an example for JSON encoding. Not reading is similar, but in the opposite process. Okay, but what happened is like, this is what I just showed you from one image to the other, right? When you code this, it's like you have to go one by one. Yeah, is this character a special character? Yes or no? If it's a no, you need to take a special, consideration in terms of, hey, increase the memory buffer, escape this character. And one of the optimizations that we did, and actually this was done a while back in version 3.2, is that we started to implement in SIMD because the primary problem was like, hey, if the text is larger or the messages are larger, we are spending more time trying to check how to encode or decode these special characters, right? And of course, it becomes really, really expensive. And we were looking for a way, hey, what about if instead of checking 1 byte at a time, we can check as a minimum 16 bytes at a time? Of course, that will be a huge optimization, and SIMD allows us to do that. So going back to the same example, imagine that we have this text that says, hello world, this is a great, and I will generate cool stuff, blah, blah, blah. Okay, so when you're doing SIMD operations, we start, instead of scanning 1 by 1, what we do, we scan 16 bytes at a time. Okay, on these 16 bytes, we will try to match any special character. And these operations runs in parallel, right? I will say, hey, do we have any special characters here? No, we just have one empty space, but that's fine, that's allowed. So we just copy the straight 16 bytes, and we don't do a check for 1 by 1 because we just did one instruction to check 16 bytes at a time. In the next one, we said, oh, we're going to check the next 16. Is there a special character? Yes, there is. Okay, so when there's a special character, that's when you have to go and do the manual process. So it's not magic for everything, but we have found that in majority of cases, the special characters are not in the majority, usually are 20%, right? But you don't want to spend everything in making more CPU cycles. So in this case, you do, we scan 16 and we just copy and encode. The next one is a straight copy. We just copy 16 bytes. There's nothing that we need to be escaped. In the next one, yes. So we have to escape one block here because we have a special quotation mark that needs escaping. And for the next one, yes, we have another one. So we can have multiple ones. So at least if one matches means, oh, this needs a manual processing. Otherwise, optimization is just copy the 16 bytes in one row. So in total, with this mechanism, with this just text example that is kind of normal, is not optimized for a better result for this presentation, yeah, you might end up with 71 operations in total. Just a general overview. But before using SIMD, they were around 90. And if you consider that Fluent or any kind of log agent is working 24/7, processing thousands and thousands of messages per second, this matters a lot because this will end up on having more CPU usage or less CPU usage. we ended up on energy, efficiency, throughput, and all the side effects of this. Okay, so basically this is how do we use a SIMD in order to scan text in a very fast way and to know if we can skip certain parts of processing by knowing with the parallel processing that, hey, there's nothing that needs to be encoded. Okay, and in last December, when we released a Fluent Bit 3.2, I think it was in KubeCon US, okay, our JSON packer is the JSON interface that we had in Fluent Bit that takes care to encode to JSON. Okay, so when the data gets into Fluent Bit, no matter what is the source, we encode it in a binary format. It's similar to JSON, but it's binary. So, but we support all the data types. It's called a message pack format. But however, when you want to send the data to the destination, most of the endpoints like that supports a HTTP, or for example, even if you want to send them as Slack messages, or you want to send them or store it on Amazon S3, sometimes the user prefers to have this information in a JSON format, or the endpoint needs a JSON format. So we need to convert from the binary representation of message pack to JSON. And in last December, we just improved this writer, so how fast we can do this process here, but when writing to JSON. That's the improvement that we did in 3.2, and actually had been quite successful. While SIMD was not enabled by default in the packages that we serve, we found cloud providers and other partners from the project using this extensively and providing feedback like, yeah, this is working great. Now, how SIMD looks now in version 4.1, right? This was SIMD support introduced in December. Now we are in September. And one thing, SIMD is not, there's special instructions that provided by the processors, okay? But SIMD instructions has been around, I think, for 15, 20 years. So it's really hard that you find that processors that don't provide this type of optimizations. But let's take a look at what is new on this one. The first one is that we have extended the architectures, meaning the type of processors that we support to operate with SIMD instructions. So we extended to RISC-V, and now for ARM64, we support Neon instructions. And pretty much on ARM, we support Linux, macOS, and Windows ARM64. Of course, x86-64 was the first one, and we have gradually extended the support to new architectures. How this is added? Pretty much based on demand, or when some contributor or maintainer said, oh, I have this architecture, this is not supported, I would like to extend. We have a very simple interface for SIMD operations that operates based on the processor that it was compiled to run. So most of these instructions that we use, pretty much we use SSE2 in general, because this is 16 bytes. This is kind of the minimum that exists for SIMD, so we can be compatible with everything that it's around in the ecosystem. Okay, so basically, and actually in this image, you can get a representation where you can get multiple sources of data, you apply one instruction, and you can get multiple results. Okay, so what is new for that one? The JSON parsing, which is now the opposite of what I just described, was JSON writing, now got 2.5 times faster, right? That it's insane, and it's a lot. Actually, if you compare what is a SIMD enabled versus SIMD disabled, before, we were processing in just one single test, right? Because we wrote a simple benchmark tool to compare the non-SIMD version with the SIMD version over a large JSON text. Before we were able to process, at least in one of my development machines, 131 megabits per second, right? But when enabled SIMD, this jumps to 334, so 79 megabits per second. Now, of course, there'll always be a fluctuation based on the type of data, the type of hardware that you have, the load of the system, but you can trust that 2.5 is a minimum that you will get when reading data that comes in JSON. And this could be OpenTelemetry JSON, could be, for example, if you're deploying in Kubernetes and you're using the Docker container and Docker container logs comes in JSON, yes, you're going to benefit from this right away. Of course, you need to make sure that the container image or the binary that you're writing has a SIMD enabled at that moment. Okay, another plugin that is used a lot is Tail. I would say that's one of the most well-used plugins in FluentBit. And Tail, what it does is to just read log files, right? And I would say that is one of the most complete and complex plugins because it had to handle multiple files at once. You need to get notifications when files get appended with new data, or files be monitored and get dropped or get rotated. And we found that, hey, when we're reading log files, one of the things that you care about is like you can have a huge log file, right? But really you care about where is the break line for each line, because each line represents a log entry, a record. And if you think about similar to JSON, where we need to check where this line ends, because we need to approach. So the thing is, this way it works is like we take a file and we load a part of that file in memory in a buffer. And in that buffer, we try to determine, hey, where are the lines, which are the lines, so we can start process each line as an independent record. And with the new SIMD improvement that was done, Hiroshi, this is work here, it was like now we were able to increase the throughput on reading files by 3 to 5%, of course, based on the type of data that we are reading and the size. And that also improved the efficiency in CPU and memory. So based on the configuration that you have in Tail, for example, file buffer, when you read a file, you have a buffer for that file. If it's set to 32 kilobytes or 128 kilobytes, based on if SIMD has been enabled or not, this is kind of the baseline that we got for each one of them. One thing that we noticed, and this is really important for anybody who's deploying FluentBit in production, is like when dealing with log files and we're reading chunks of a file and allocating so many memory buffers, then free them and so on for optimizations, depending on the system that you are running, you can get memory fragmentation. Okay, for example, glibc will fragment the memory a lot based on the usage that is required by FluentBit. However, in our container images, we provide FluentBit enabled with jmalloc, which is kind of an alternative memory allocator, right? And that memory allocator is very well known to reduce the fragmentation a lot. So ideally, when you deploy this in production, you would like to have a good buffer size for reading this information, enable SIMD, and you will get a good results compared to one version to the other. Of course, the results that we have here is with just monitoring one file, but exponentially, if you have more files with different rates of data ingestion, of course, this will add up in terms of will be more efficient, and you might get other type of good results in your scenario. So SIMD has been extended on these parts, everything that is JSON parsing for reading, and when telling files. Of course, there's still more room in FluentBit to implement more SIMD operations in other components. And actually, I think that we're heading on that direction. You will notice that I think that in general, most of programs just use the basic of what a CPU provides. And now we're trying to get, maybe we can use a special instruction so we can get better results for everything. Okay, besides the performance optimizations, there's a few new features in FluentBit that has been requested, and let's talk about them. So the first one is like a new GPU metrics input plugin. For anybody who's running an environment with AMD GPUs, now this input plugin can gather the metrics, and those metrics can be exposed in Prometheus or OpenTelemetry format for analysis. Other requirement that we got a lot was like, hey guys, you support a style of node exporter for Linux. You have some Windows exporter for Windows inside FluentBit, the same binary. But many users were saying that, hey, I have my archive application, very old application that we modified to write metrics and write them to a text file, what is called a prompt file, which is metrics in a prompt file, and would like to expose them. So in our implementations, we didn't have a way to read those prompt files. So now we have a new Prometheus text file input plugin. So you just point it out to the files, it will scrape the metric, same as it was scraping an endpoint. And so you can make this all these Prometheus metrics available for you. And the other that was just recently added is like a new supervisor mode. Fluent when it runs as like a simple single binary, right? Fluent itself is a shared library, but we compile it statically with the binary. And what it does is like, yeah, it just works, right? It starts to running and so on. However, there are certain environments and scenarios where you would like to have another way to monitor this process that is running pretty much the pipeline, right? For example, if you're doing hot reload, there might be a certain scenario where, hey, maybe something might hang Fluent, there might be a bug here and there. And so those are really hard to catch. So we implemented a supervisor mode, which is optional, disabled by default. What it does pretty much is like a parent process that watch the Fluent pipeline that you started with your own configuration. And if a restart or any type of signal is sent to Fluent, it will forward the signal. And if a restart was shown down, was instructor. And for some reason, the grace period for Fluent didn't work in terms of starting to delay a lot. With the supervisor mode, you can be more strict and actually stop or fully restart that child that was there. Before this, yeah, you had to just wait to what was happening with the service. Of course, if you're running in containers, you might not need this. This is for other type of use cases for VMs, bare metal machines, or any type of deployments where you need some kind of supervisor mode. In the cloud and output connectors, we have seen a lot of extensions on the plugins that we have. For example, our OpenTelemetry output plugin now supports AWS authentication support. And we implemented also some more robust log and attribute handling. A couple of fixes that we also backport to version 4.0, but pretty much the AWS authentication support is a new thing. In the Amazon S3 connector in the output, now we support blob support. Blob is like a new internal, not new, it has been there for a year, internal inside Fluent where we have a blob input plugin that instead of streaming data like message per message, you can give it a big file, right? For example, 1 gigabyte file, a movie. Imagine that you're a movie, and that will be transferred and the content of that file will be sent in the right order to the destination. So we added that support for Amazon S3. It uses a zero copy strategy, so there's no double buffering, which is really good. Also for Amazon S3, we implemented a Z standard compression support, which of course gives more compression and is faster than the standard zip or gzip. And the most requested thing has been Parquet and Arrow format. So you can take your logs with the structure that you want and of course format that as a Parquet and send it to Amazon S3. And of course, why this format is important because there are other services in Amazon that can take advantage if your data comes in Parquet. Okay, and all around authentication with cloud providers, Amazon CloudWatch, we have the new entity support and similar thing for Azure Custom, we have workload identity. Okay, these are more internal cases. If you're using CloudWatch or Azure Custom from Microsoft, you might benefit from it as well. These contributions, of course, comes from the cloud providers. In networking and security, we have replaced the NPN stuff for TLS with LLPN, which of course is the right thing to do. We have a configurable search store for Windows, a new proxy improvement. Now we got some not critical cases, but some corner cases where maybe the environment where Fluent was running was set to use a proxy, but certain plugins, the users wanted to use a different proxy, but they could not modify the thing globally. So we implemented a new way to ignore the proxy settings that were set globally for the output plugin, and the output plugin can set its own specific proxy settings. The other, we have enabled EDNS for large DNS responses. Usually DNS responses are not quite small as they used to be. Yeah, and the extended DNS has been enabled inside Fluent. other side things, observability metrics, now you will notice that the Fluent bit logs will come with nanosecond precision. Okay, now we have a new histogram for chunks latency in Fluent bit. So you inspect the internal metrics, you will see that you will be able to see how much latency is being existed for certain chunks. This is using a histogram. So yeah, if you're using any platform that support histograms, visually, you can have a more granular control of how the data is flowing through your pipeline. And in Windows exported collectors, yeah, in general has been extended with TCP, paging cache, logical disk, and typical collectors that were existing in the original Prometheus version now has been added here. Okay, so well, this is a very high level overview. I think the most interesting thing is around performance. And besides that, as you know, for every major version of Fluent bit, we have a signature design, which becomes later a t-shirt, right? And we launched this t-shirt at KubeCon. So if you are around in KubeCon, in this case for KubeCon in Atlanta, I think it's Atlanta, if not wrong, you're going to get access to the new Fluent bit t-shirt, of course, that we distribute for free. Okay, so if you are around, of course, make sure to approach to the Fluent bit booth so you can grab your Fluent bit t-shirt. Yeah, so I think that was the quick overview of Fluent bit 4.1. I appreciate your presence today here. And if you have any question, we'll love to maybe give some minutes so you can share if you have any question related to the Fluent bit release. Okay, so no question for now. I appreciate your time, and you will hear more about other Fluent bit 4.1 features. And the release is happening between now and Monday. We're still finishing up some things, but at least you are getting some highlights. Of course, this is being recorded on September 19 in case you watch the recording at a later time. Okay, thank you so much and enjoy your weekend.